Hey there. A friend of mine sent me a text. I got this text a little while ago. It says, "Hey, can you show me an example of multiplying and dividing decimals using CRA? I can do it with whole numbers, but cannot recall how to do it with decimals. Thank you." All right, so here's the thing. First off, what is CRA? CRA stands for concrete, representational, abstract. C stands for concrete, meaning first we're going to begin showing how to do stuff. And in this case, my friend wants me to explain multiplying decimals. We're going to divide this up into two different videos. First video is going to be on multiplying decimals. The second video is going to be dividing decimals, and I'll connect those in the show notes. So CRA says, first we're going to introduce that multiplying decimals concept concretely. In this case, we're going to use base 10 blocks. And then once we've got the base 10 blocks under control, we're going to start drawing pictures of those base 10 blocks. That's the R, standing for representation or pictorial, a representation of the concrete manipulatives, in this case base 10 blocks. And then eventually the student starts to be able to understand how to do this concretely and pictorially, and then the student is going to begin doing it with abstract, just the plain old numbers. And that's the process. It's an instructional approach that guides students through these three developments: concrete, representation, and abstract. So let's get started with some concrete. Now, because we are on a video, I was having a hard time showing my, like getting my iPad to show the actual base 10 blocks. So I'm going to use some virtual manipulatives. There's some research out there that says using virtual manipulatives is kind of the same thing as using physical objects. So we're going to sort of hand wave a little bit and pretend that that is true. I hope it's true. So the idea of this is, so when we are doing 0.6 times 0.4, or 6/10 times 4/10, all right? So the idea is, what is that? First thing we're going to do is we need to model that. Well, we know if I started with a couple of these things, all right, this, and I want to color them. Let's make them green, all right? Good. All right, so this is a 1 by 1, all right? So this whole thing, and let's do it in green. This whole piece, this yellow piece, is equal to one whole. All right, that's what that thing means, that whole yellow piece, because it is 1 by 1. All right, there's our 1 by 1. But we're being asked to multiply 6/10 by 4/10. Whoa, I want to undo that. How do I undo that? I want to make that go away. How do I make that go away? Help. No, I don't want to do that. There we go. I'm going to make this, I want to make this go away. Go away. Good. There we go. Awesome. All right, so I'm going to make that go away. There we go. And so now I'm going to let this, let's make this go here. There we go. And I'm going to make this, there, represent our 6/10. So what is our 6/10 going to look like? Well, there's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So there, right here, is my 6/10, 0.6. And in the same fashion, I want to have, there we go. And I'm going to make this be our way over here. I guess, no, I'll do it way over here. And then here's my 4/10 right there. All right, so do you see my 4/10? In fact, well, yeah, let's do it right there. So there is my 4/10. I'm going to do this in, let's say this is orange. So there is my 4/10. All right. So if we wanted to see what that whole rectangle is, it's right here. Here is a rectangle that represents a rectangle that is 6/10 wide and 4/10 tall. All right, and then I'm going to do a little bit of erasing because I got a little excited with my erasing there. All right, so there is my rectangle that represents 6/10 wide, 4/10 high, or tall, I guess. All right, now when we look at that, we can see that there's going to be 24 little squares. All right, so this area is these 24 little squares. But what are these 24? 24 what's? Well, if the entire thing represents, I wish there was an undo button here. There isn't an undo button. There needs to be an undo button. I want an undo button. So if this whole thing represents one whole, that whole yellow thing, these 24 little squares represents 24 out of 100, which is 0.24, 24 hundredths. So 0.6 equals, 0.6 times 0.4 equals 0.24. Now, if we wanted to look at that in pictorial form, and that's kind of what I did over there is pictorial, but let's make it even more exact. So here is our picture, and we're going to say this distance right here is 1, and we're going to say, and I'm going to scooch this baby aside a little bit. There we go. And then we're going to say this is equal to 1 whole. So that means the entire square, 1 times 1, is equal to 1 whole. All right. And so if we want to show 6/10, 6/10 is going to be 1, 2, 3, 4, 5, 6. Right here is 6/10. Similarly, if we want to show 4/10, we're going to go 1, 2, 3, 4 right here. So this, I'll do it right here, is 4/10. So now we're going to connect those lines. That is our rectangle that is created by multiplying 6/10 times 4/10. And then so this whole area right here is our answer. And we can see we've got an area of 24 little tiny squares out of the whole thing, which is 100. So we have 24 little things right here out of 100 total right here. So that equals, so I'm going to erase this and say, so that equals 24 out of 100, which is 0.24. All right. So now that's a picture. Let's not go to the picture. Let's go back to the concrete. Let's go over here. So I'm going to erase this whole baby thing. Erase that whole thing. Go. All right. And what was the problem we're going to do? We're going to do 1.6 times 0.4. All right. So let's do 1.6 times 0.4. All right, so now we need to create a rectangle that is 1.6 across and 0.4 tall, or vice versa. Oops, and I keep forgetting to make that go away. All right, so there is our 1. This is going to be our 0.6, but that's more than 0.6, isn't it? That's 2 holes, right? And then similarly, here is our 1 hole. And you can see I'm kind of cockeyed there. Zooming in on that corner, you'll notice they're not put together the way you might. You might want to do it like that, or you might want to do it like that, but that's not right. So we want it right there. All right, perfect. All right, and I want these to be green because I don't know why. I want that to be green, and I want that one to be green. Good. Now, 1.6, that's 1 whole. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Right there is our 1.6. And similarly, our 0.4. There's 0.1, 0.2, 0.3, 0.4. Oops, that's 0.3. There we are. There's our 0.4. So what we're trying to do is we're trying to figure out what is this rectangle going to look like that is 0.4. That is 0.4 all the way over here, all the way up here, all the way over. And so we're trying to figure out the size of that rectangle. So we're going to bring in a hole, and we know that that hole equals one hole. And then we're going to bring in another one right here. All right. And so we can start to see that 1.6 across by 0.4 tall. If we were going to count all of our little pieces, and let's do a color. Let's make it black. So right here, it's going to be 0.4 times one whole, which gives us 40 little tenths. 40 little hundredths, right? If you counted them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, you get the idea. We would have 0.4 of them. We would have 40 hundredths. And then same over here. We'd have 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. So we're going to have 24 hundredths over here. And over here, I could rewrite it as 40 hundredths. So adding that together gives us 84 hundredths, which is 0.84. Bam. And so what we're doing here is we're really trying to build that rectangle. And we're doing it concretely. Now let's do it pictorially. So if we want 1.6, well, right now we only have a 1 by 1. So I need to add on 6 tenths more. 1, 2, 3, 4, 5, 6. And then I'm going to go down. All right, there is my 1.6 going across. 1.6. But I only need 0.4. So if I wanted to, I could go 1, 2, 3, 4. So right here is my 4 tenths. So really, I want this rectangle right here. Right here. So we know each of those little squares is 100th, don't we? And we know that this is one whole and this is 6 tenths. So 4 tenths times one whole gives us 40 hundredths. And that 4 tenths times 6 tenths gives us 24 hundredths. And if you want to be thinking about this, you could say, let's stick with this and let's keep finishing here. So this is 84 hundredths. So we know it's 84 hundredths, which is 0.84. That's pretty cool. That is pretty darn cool. Now, by the way, if you want to kind of start to move towards that algorithm, that A, so we did the C, the concrete, we did the R, the picture. Now, you really want to start thinking about what is this going to look like in terms of the abstract. Here's an idea. You could think of 1.6 as 10 tenths plus 6 tenths times 4 tenths. And so we knew that we were going to end up with two partial rectangles. Here's one and here's the other. So one rectangle was going to be 10 tenths across by 4 units or 4 tenths tall. And then the second one was going to be 6 tenths across by 4 tenths tall. And so here's our 40 hundredths. Here's our 24 hundredths. And you add that together, you get 84 hundredths. So there's another way you could be thinking about it as you're starting to get towards that abstract. All right, let's skip right to 3.4 times 1.7. So what does that look like? What is that going to be? That's going to be a rectangle going across, and it's a rectangle going down. So here is my pretend rectangle. Well, no, it's a rectangle, but I'm not trying to draw it like accurate. And that rectangle is going to be 3 units across plus 4/10. And I'm going to write it like this, 4/10 across. And then it's going to be 1 unit down, 1 unit down, and 7/10. So I'm not trying to draw it accurately, because if anything, it looks like my 4/10 is longer than my 7/10, and that's silly. Okay, so now we've got 4 separate rectangles, don't we? So this rectangle is 1 by 3, which means it has an area of 3. This rectangle right here is 1 by 4/10, which means it has an area of 4/10, because 1 times 4/10, anything times 1 is itself, right? And then down here, this rectangle is 3 by 7/10. So that means we have 3 copies of 7/10, which means that's 21/10, which is 2 and 1/10. And then lastly, this little rectangle right here is 7/10 by 4/10, which is equal to, and I'll do this in red, is equal to 28 hundredths. Why is it 28 hundredths? Because remember, it's going to be 28 little squares, and it takes 100 little squares to equal one big whole unit. All right, so now we have this area, which I'll make in red. We got this area also in red. And then we've got this area, lastly, in red. So our job is to add all of those up. So you've got 3 plus 4/10 plus 2 and 1/10 plus 28 hundredths. My goodness. And if we are going to add this up, I'm just kind of, there we go. So we have 5 wholes. 2 plus 3 is 5. 4/10 plus 1/10 is 5/10. Plus we have an extra 28 hundredths. And I'm just kind of really all over the place in terms of how I'm writing it. It doesn't have to be all perfect. Well, how do we add 5/10 plus 28 hundredths? Well, 5/10 is the same thing as 50 hundredths. So all of a sudden we end up with 5 and 78 hundredths, which is 5.78. Whoa, we're all over the map here. So this is kind of a neat way to begin with those manipulatives. Start off with your base 10 blocks, move to your pictures, and eventually you can start moving towards kind of unorthodox, unstandard algorithms. But this is how we're going to move towards that standard algorithm. So as we move, 3.4 times 1.7, we could be thinking of this as 3 and 4/10, and we could think of this as 1 and 7/10, and we can multiply, and we could kind of in an unorthodox way. Let's start with 1. 1 times 3 is 3. 1 times 4/10 is 4/10, and then multiply by 7/10. 7/10 times 3 is 21/10. 7/10 times 4/10 is 28 hundredths. And now we're going to add all of those together. And that's kind of a neat way to do it if you want to think about it that way. So you get 3, 4/10, 2 and 1/10, 28 hundredths. Mushing these together, Putting these together, you get 5 and 5/10 plus 28 hundredths. And that's where you get your 50 again, 50 hundredths. Kind of neat, huh? So you end up with 5 and 78 hundredths, which is equal to 5.78. Wow. Boy, there's a lot of neat stuff. I'm kind of discovering this all as we go. All right, so that is wrapping up using CRA to show multiplication. In a second video, I'm going to show you how to do that same kind of process with division.